Ifadaminka, I see you in the building. Yeah, so I'll just quickly solve 20 questions in physics. We'll continue from where we stop in the evening. We are doing math, so I'm doing math. We will solve just 1 to 22 or 1 to 10 anyhow. Then we'll continue with our math question. I want to deal with my math. Just say in the next 30 minutes. In the next 30 minutes, we'll be back for. In the next 30 minutes, we'll be back for mathematics. Let's start the movements. In the next 30 minutes or in the next 40 minutes. Okay, let's see you in the building. Let's just give let's share the life. So let's make ourselves happy for how many minutes should we make ourselves happy? Let's make ourselves happy for 2 minutes. Let's make ourselves happy for 2 minutes. Let's go. I see you. Welcome, guys. God bless you. God bless you. Hey. Hey, MB1. 4 minutes. Are you sure 4 minutes is not too? It seems this thing is not standing well. Okay, come. You are just joining, welcome in. Let's make ourselves happy for a few minutes. Charger is not working. See you in the building. Where are you? I see you. Good evening, Ayomi. I see you in the building. I see you. Hey, I didn't come with my charger for speaker. The speaker is down. Let's see what we can do. If this will be able to. It's not giving us the sound. There's nothing we can do. The phone is not good. The phone can only play when it is connected to speaker. The speaker is down. Okay. Happy Sunday, MB1. I say you're the beauty. Philosophy and sociology. I don't know that. I say you in the beauty. Where are you connecting from? Drop it in the comment section. Let's go. Remain 2 minutes or 1 minute rather. 1 minute we kickstart the physics before we dive into the mathematics. Let's go. Who's in the building? Drop where you are watching from. Cleanmaths all the way from Lagos City, Nigeria. I see you. I'm in the building. I face show. My shoe shine. I got it dons. Those states, if Father Mega, your face show, your shoe shine, you got it dons. Ayomi, Castina, your face show, your shoe shine, you got it dons. Who else is in the building? Taraba, MB1, your face show, your shoe shine, you got it dons. Oh, Joseph Z, Joseph Eze, we see you all the way from USA. Your face show, your shoe shine, you got it dons. Lusaka, Zambia, Carlos Jr. We see your face show, your shoe shine, you got it dons. All the way from Abuja, Tatika Odudu. Your face show, your shoe shine, you got it dons. Who else do we have in the building? Just 1 minute to go. Who else do we have in the building? Thanks for the likes. Let's share the live. Who else do we have in the building? Thank you, Micah. I see you in the building. See you in the building. You got it done. 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 I see you. Joseph is in the building. You got it done. You got everybody in the building. Hey, you got it done. I got you in the building. Got it done. Oh, Rona boy, all the way from Lagos, Ikorodu. You got it done. Say, you got it done. I see you in the building. You for dark and the beauty. Oh, my viewer, you're highly welcome. I got you. If you are just joining, drop where you are watching from. Let's give you the heat. Let's give you the heart. We see you in the building. I see you in the building. I got you. Let's go. At the count of 10. Let's go. Let's go. Let's go. 1. Let's go. 2. Let's go. 3. We see you, Magdalene. All the way from Lagos. I got you. It's Prince Abuja. We got you. We got you in the building. Your face show, your shoe shine. You got doing 4. Your face show, your shoe shine. You got doing 6. Your face show, your shoe shine. You got doing 7. Your face show, your shoe shine. You got doing 8. Your face show, your shoe shine. You got doing 8. Your face show, your shoe shine. You got doing. So let's start. So I was able to go through at least like 22 questions. Let's just quickly look at that. We're going to be doing physics, mathematics later. Physics for like 30 to 40 minutes. That's what we're going to be dealing with now. So we'll be dealing with physics. And then before I proceed, I may not be able to give you the in-depth explanation of everything I want to say, but be very sure that you understand what I want to say. You understand my explanation. I may not be able to, be fluent as when I'm solving maths, but just know that because of the request, physics. I say I got to do something. It's not that I don't know physics, but I just have to go back and refresh memory. It's been a while. You got the flow. If you are in the building, you got the flow. Drop in the comment section. I got the flow. Yeah, but if Micah, we are not in the same place. How do we do that? We are not in the same place. I got the flow. If you are around, if you are in Lagos now, one day I will have asked you to just come to my place. Then you dish out the physics. You got the flow. So let's go. The first question on our line. This is physics. Because there are the theory is more, as in the explanation is more playboy. Can you take us physics? You got the flow. Okay, let's go. So now let's quickly solve some question in physics. Then we'll come back to WAEC mathematics. Now the first question here, I'm just going to write out the data. I will write out the data given. Just listen to the question. A waterfall is 420 meters high. A waterfall 420. So let's say this is the level and the water is coming this way. So this is the height. They said the height is 420 meter. 420 meter. So a waterfall from a height of this. So that is what you are having. They said calculate the difference in temperature. We have to calculate the difference in temperature. Then of the water between the top and bottom. This is not Nigeria. So this is not Nigeria, from top to bottom or from bottom to top. So now of the waterfall, assuming no heat loss. These are the key points. No heat loss. You remember, under heat transfer, there is heat gain. Heat gain is equal to heat loss. So now there is no what? The question says there is no heat loss. So if there is no heat loss, and we are giving specific heat capacity of water, to be equals to 4.20 times 10 raised to power 3 joule kilogram per Kelvin. We are giving specific capacity of water. Then we are giving G, this acceleration due to gravity, meter per second. So how do you now solve this? If you are giving this, the question says that a waterfall is 20 meters high. Calculate the difference in temperature of the water between the top and bottom of the waterfall. Assuming no heat loss, we are giving specific capacity of water. So when you see this, thank you, God bless you. So when you see this type of question, all you need to do, let me just give you the secret in solving, be it the calculations, be it chemistry, physics, and other courses, maybe accounting and things like that. One thing that you need to look out for is the parameter given. From the parameter given, you can sort out whatever you want to do. So let me clean this place so that we can solve it. So now if from heat capacity, heat energy is what we are saying is mass CT. This is specific capacity of the object, and this is mass of the object. This is the temperature difference. So temperature difference in the sense that if you are having an object, if this is an object, maybe this object is at a particular temperature, and you place another metal or you place it inside water, the water will be gaining heat while the metal is losing heat. So that is why I wrote initially that heat loss is equal to heat gain. So now in this case now, we don't know the mass of the waterfall, but we are giving the specific capacity of water, then we have to look for the temperature difference. That is all. And the statement says that there was no heat loss. If there is no heat loss, now this water is at the height, which means there is an energy here. There is an energy here that is functioning. Can somebody drop the energy that is functioning at this height for me? So, can somebody drop the energy that is functioning here at this height? Is there anybody in the building? Okay, thank you. It is potential energy. You know, potential energy, it could be energy at rest or energy at a position, at a height. So that is it. So if the energy here is potential energy, what does that one give us? Potential energy is what? mgh. Are you getting? Acceleration due to gravity and the height. So which means if there is no energy loss, then the heat transfer should be equal to the potential energy. So which means at this point we'll be having mcq equals to mgh. So from here the mass will take away each other. We know g, we know h, we know c. So we have to calculate q, which is the temperature difference. So temperature difference will be equal to gh over c. So g is 10, height is 420 meter divided by the specific capacity given. The specific capacity, yes, because it has a height. So specific capacity given is 4.20 times 10 raised to power 3. 4.20 times 10 raised to power 3. So what do we have? 1 we take away one of this, 1 we take one of the, remain 10. 10 times that is 42. So 42 divided by 42. 42 divided by 42. That is 1. Isn't it? That is 1 degree. Is that clear? That is 1 degree. Degree Celsius. Is that clear? Is this clear? Continue or wait? Do we have physics student? Continue or wait? Continue or wait? Continue. Okay, you want to write this? See, listen to the question, because the question is many, and my marker is not many. So if I should be writing everything, we may not do anything today. So listen to the question. The question says that a waterfall is 420 meter high. A waterfall is 420 meter high. Do you see that? And calculate the difference in temperature of the water, which means the temperature at this level and the temperature at this level. The temperature at this height and the temperature at this height. So you should calculate the difference of the water between the top of the waterfall. Assuming no heat loss. There was no heat loss. So because there was no heat loss, that was why we were able to equate the energy at this point and the energy at this point. The energy at this height and the energy at this height. And the energy here is potential energy. The energy at this point is potential energy. So now, because you know from our heat transfer, we are having Q to be equal to mc theta, mass, specific capacity of the object, and the temperature difference. This one is Q2 minus Q1. So if you equate, if there was no heat loss, then the heat at the bottom is equal to the heat at the energy. The energy at the bottom is equal to the energy at the height. That is why we equated them. In the question, we were not given the mass, so that's why mass cancel each other. If you make Q the subject of formula, which is the theta rather, not Q, theta. You make theta the subject of formula, which is the temperature difference we are looking for, is equal to the acceleration due to gravity and the height. So, which is, we were giving the G, and we're also giving the height. So, divided by, we're giving the specific capacity. Just press your calculator. Press your calculator. You'll be having, this is 10 times 420, that is 42. 4.2 times 1000, 42. So, the temperature difference is 1. Thanks for the gift. God bless you. I see the finger. I see the finger. So, we are going to move very fast. I'm going to move very fast because, you know, mathematics is general. We have a lot of people that are doing mathematics. So let's move fast. You have to listen to this. They say a body, when slightly displayed, is said to be neutral, equilibrium. Only if, let me write this one. I think I can write it. They said a body, when slightly displayed, is said to be neutral. Neutral equilibrium. Only if it tends to dash. So I'm going to read out the option. I believe you know what yes, the math class, thank you for that. Math class will take place very soon. So you know that if you have a body in equilibrium, the body will be at rest. If a body is in equilibrium, the body will be at rest. So now, let's say we are having a circle with a center of gravity. Now, this ball or this circle will remain here if this is on a circle, but if it is on an equilibrium. So neutral now, they are now saying, which means at the neutral level. So they are now saying a body, let's say this is the body, is slightly displayed. Let's say it's slightly displayed to this point, from here to this point, and we are still having, you display it here. You have it, no, there was no change here. So the options here now, is that the first option is that A is that comes to rest in a new position with the center of gravity and height remain unchanged. That is A. B. Return to its original position. That is B. C. Remain in its display position. D. Move further away from its original position while its center and mass is changed. So, J55, God bless you. God, I see you in the building. I see you. JI555. I see you in the building. So, what is the correct answer? The correct answer here, I will just go with the flow so that we can quickly start our maths. Thank you, I see you. So, the correct answer is that it will come to rest in a new position with the center of gravity and height remain unchanged. So, if a body is on a neutral equilibrium, which means it's at rest, so if you tilt that particular object, it may shift position, but the center of gravity will not change. The center of gravity here, if you look at the distance here, the center of gravity will not change. That doesn't mean that this will now shift here or it will shift there. So that is physics. So that is the answer. That means just know that when a body is on a neutral equilibrium, if you tilt it, if you displace it, the center of gravity will remain. So put that one to your score. The center of gravity will remain unchanged. The center of gravity and height, physics. Center of trafficking and height will remain unchanged. So that is the answer. I believe you will know that when a body is in neutral equilibrium, if you push it to anywhere, the center of gravity and height will remain unchanged. So we will soon go back to mathematics. Yes, we will soon go back very soon. That is why I want to move very fast now. So the next question is that I told you I will just be bringing out the parameter. This is why I don't want to solve their what is a bit many. A string of 5 lengths. A string. Let's say this is the string. We are having a string of 5 lengths. Which is let me look at the unit. 5 meter. This is a string attached to a wall or something, or a clamp, and it's 5 centimeter. Now the question now says that is extend by 0.04 meter when a load of 0.8 kilogram is suspended. Now if you now put a load, let's say they said a load is placed here, and the load is 0.8 kilogram. 0.8 kilogram. So okay, wait. When you place a load, they say this thing extend by 0.04 meter. By the time you place a load, of 0.8 kilogram. So a spring, you know, that is being attached to the wall has an initial length of 5 meter. Now when a mass or a load of 0.8 kilogram being attached to the string, the string expanded. You can try it. If you have any spring, just place a bit of weight under it. You will see what I'm saying. Are you getting me now? The spring will expand a bit. The spring will expand. That is the same thing that happened here. So the question we are now having now is that the question is now, how far will it extend if a force of 16 Newton is applied? So if you now apply a force of 16 Newton, so how long? If you apply a load, let's see. So the string should extend from here to this place, which we don't know. So you now apply a force of 16 Newton here. You see now. I hope you are getting the flow. I hope you are getting the flow. Now the question says that a spring which is of 5 meter in length, when a load of 0.8 kilogram was applied, it extended by 0.04 meter. Now they are now asking, how much more will it extend if you apply a load of 16 Newton? This is force. The unit of force is Newton. So now this is how you calculate it. Now you can convert this mass to a force. Don't forget that force is equal to mass times acceleration, which is, in this case, since we are dealing with gravity, you can change it to gravity, acceleration due to gravity. Now it means that this mass now is 0.8. If you are not giving acceleration due to gravity as 9.8 meter per second square, you can also use, yes, that is Hooke's laws. You can also use 10. So 10, which is this. So this one will give us 8 Newton. Look at something. Is something telling you? Are you getting something here? If a load of 8 Newton is producing 0.04, how much will 16 Newton produce? If a force of 8 Newton is producing 0.04 meter in length, so how much more will 16 produce? How many times can you find 8 in 16? Is it not 2? So which means it's going to extend by 0.04 times 2, because this one alone is extended by 8 Newton. So now we are now having 2 of the load, 2 times the load. It's like we are having 16 here, we are having 18 Newton here. So if here is 8, this should be what? And it's extended by 0.4. And we are now having double of this, double of the load. Then we should have double of the length. So we should have double of the length. So are you getting me now? So the answer should be 0.08 meter. So that is the answer. I hope that is clear. Continue or repeat. Continue. Oh, thank you all. I really appreciate your gift. Continue or repeat. So we want to go. Let me continue, because we want to quickly solve. Let me just say 1 to 20 questions Then we start with our mathematics. So the next question here is they say which of the following has a negligible mass? A negligible mass. A, we have protons. We have protons. B, we have gamma ray. We have gamma ray. C, we have beta particles. Then D, we have alpha particle. So this thing is just by mass. So the simplest one here is proton. You know, proton is just a subatom. So that is a proton. If you look from chemistry, we are saying hydrogen. No, we'll be looking at, if you are writing the ion of hydrogen is H plus. This is atom. Atom and atom, if you are having a gas, nitrogen gas or so, then the ion in it is just +1. By the time if you look at the mass of proton, it's very, very small. It has the least mass. You can Google, just Google it and correct me here. So I told you I may not be as perfect as when I'm solving mathematics, but just know that I can still explain something that you understand. So the answer is protons. If you look at proton, gamma rays, alpha particles, and which other one again? Beta particles. So the least of them that has the lowest mass is protons. So the next question is calculate the upthrust. We are calculating the upthrust. Calculate the upthrust. Where are we? Calculate the upthrust of an object of volume 50 centimeter cube. Volume 50 centimeter cube, which in mass in liquid of density, we are giving density of 1000 raised to power 3 kilogram per meter cube. We are giving acceleration due to gravity as 10 meter per second. Now I believe you know what is an upthrust. Now if you have a water, if this level is a water, if you drop an object, let's say you are dropping an object, this is the object. The force that do not allow this object to sink is what we call upthrust. Is a force. This upthrust is a force. Are you getting me now? That is why that's why we said Archimedes principle. Archimedes principle work in this way. Then in secondary school there's a way we normally define Archimedes. But Archimedes states that when an object is partially in mass, is partially or whole, is partially in mass or is in mass, all the body is mass into the water. The water display or the amount of the amount, I don't want to use water now. The amount of weight display is equals to the weight of the object. Now what I'm trying to say, if you put cup, if you fill your cup with a water, and you drop an object into that water that is filled to the brim, if you drop the object, some water will be splash up, some water will overflow. If you measure the weight of the water that overflow and the weight of that object, it will be equal to each other. That is what Archimedes principle is saying. Now let's now calculate. Somebody say I should read the question again. Here is the question. Calculate the upthrust on an object of volume 50 centimeter cube, which is in mass in liquid of density. We are giving density. So I told you, when you are solving physics or chemistry, you quickly look at what you are giving there is volume, there is density. Are you getting me now? But you need force. Now, what is density? Density is mass over volume. Is mass over volume. That is density. So if density is mass over volume, then what is mass? Mass will be density times volume. Now look at something. The density is in meter per second, meter cube, which means meter cube. There is no way the unit of volume will take away the unit of the density. I hope you got the flow. You got the flow. There is no way the unit of the density will take away the unit of the volume. So two things are involved. Either you convert the density to kilogram per centimeter cube, or you convert the volume to meter. So the easiest one is for us to convert the volume to meter. How do you do that? You must know the relationship between meter and centimeter. So what is the relationship between meter and, we have 100 centimeter will give us what? 1 meter. 100 centimeter will give us 1 meter. Are you getting it now? So 1 centimeter will give us what? 1 over 100 meter. Are you getting me now? If I'm to get cube, you see now, if I'm to get cube, I need this centimeter to be centimeter cube. I'm just showing you the way you can convert. So I need this centimeter to be cube. So I'll cube the both sides. So this one will become 1 centimeter cube will be equal to 100 raised to power 3. 100 times, this is 10 raised to power 2. That is 1 over 10 raised to power 6. Are you getting me now? This will give you 10,000. If we do 100 times 100 times 100, it will give you 1,000. But this one will not be in meter cube. Now you will be able to bring out the relationship between centimeter cube and meter cube. So this is the relationship. Converting this 50, it will be 50 centimeter cube now. 50 centimeter cube now. What will it be? If 1 is giving us this, so 50 will give us 1 over 6 raised to power 10 times raised to power 6 times 50. So this value here has given us meter cube. Now it is this value now I'm now going to use in solving. Let's look at mass. Just take note of this. Let's calculate mass. Since we know that density is equal to mass over volume. So mass is equal to density over volume. Why am I calculating mass? We are looking for force. And the only way I will get force is when I get mass. Force is equal to mass times acceleration. So once I get the value for my mass, I will be able to get the force. So now, if mass is acceleration and density times volume, that will be equal to, density is what? 10 raised to power 3 multiplied by, what is see our value here, 50 divided by 10 raised to power 6. 10 raised to power 6. So what will that one give us? This is 3040. We take away, so we are left with 1 times 5 over 10 raised to power 2. Because this is 60, this is 40. 40 will take away we take away 40 from 6, remain 2. So this will give us is 0.05 kilogram. 0.05 kilogram. Therefore, force, which is the force we needed, the upthrust force we need. So the upthrust force that will sustain the load, that will not allow the load to sink. That is what we're. Are you getting me now? It is the upthrust I've explained that it is when an object is placed in an ocean or in the water. So the force that will not allow it to sink is what we refer to as upthrust. So now we have known the mass of the object. So it will now be force is mass times acceleration, or which is 0.05 multiplied by acceleration due to gravity, which is 10. So which is 0.5. Because it is force, Newton. I hope you get it. So the answer is 0.5 Newton. I hope that is clear. Repeat or continue. Repeat or continue. Repeat or continue. Repeat or continue. We are still coming back to mathematics. No, we've done a bit of it in the afternoon. We'll continue from there. So, okay, let's continue. So, that is how you calculate that. You know, all this in relationship, big, small relationship, is what that will help you in WAEC or in your JAMB. So, the next question we are having here is that which of the following will appear when a white screen marker which of the following will appear when where are we? Which of the following will appear when a white screen is illuminated by red and green light. So for those who can relate with color, if you can relate with color, you understand. So I'm going to give you a diagram, a Venn diagram. You just need to memorize it, because this type of question normally comes. You just need to memorize it. When you mix red and green together, what you have is yellow, not rainbow. Is yellow. When a white screen is being illuminated by red and green, you have yellow. So I'll just draw let's say we are having, you know, the primary color. What are the primary color? Who want to tell us the primary color? Who want to tell us the primary color we have? Okay, primary color, we have red, we have green, and we have red, green, blue. These are the primary color we have. So these are the primary color we have. When you mix red color, green color, and blue color, what you will have is white color. When you mix the three together, you mix red, here is red plus green plus blue, you have white color. That is the first. So the next one is that when you now mix red and green together, you have yellow. When you mix red and green together, you have yellow. The question says white screen is illuminated by red and green light. So they are saying you should find what is the result. Which of the following will appear when a white screen is illuminated by red and green? The options are, we are having a red, B purple, C yellow, D green. So the answer is yellow. So we also have, when you mix green and blue together, you have cyan. Is it cyan? That is CYAN. You have this color. When you mix this and this together, that is what you have. So you just have to memorize this circle, in case whenever you have that, you'll be able to deal with it. I hope you are getting it. So when you mix blue and red, you have what we call magenta. Magenta. So this is what you have. So just memorize the color. Memorize the color. So we are moving to the next. I can just screenshot. Should I clean now? Let's move to the next question. So the right answer is yellow. Should I clean? Clean, go, continue, wait, clean. So the next question on the line is refraction. We're having refraction. We're having two. We're having we have interference. Three, we are having diffraction. So now the question is now telling us that which of the above property are common to all waves? So they are now asking you which of these property are common to waves. So which of these property are common to waves? We have A, which is 1 and Roman figure 3 only. We have B, which is 1, 2, 3. We have C, which is 1 and 2 only, and we have D, which is 1 and 3 only. Now, when you see this type of question, the answer is B. Is all of them. It's not 1 and 3 alone. It's all of them. When you are talking of waves, you will be talking of refraction. You will be talking of interference, and we'll also be talking of diffraction. Are you getting me now? We'll be talking of refraction, we'll be talking of interference, and we'll also be talking of diffraction. You know, when you are talking of, let's just do a bit of drawing. If you have something like this, and this is an obstacle, if you have rays of light hitting this place, this is the initial rays of light, and because it met an obstacle and divided, this is what we call reflected ray. Because we have a ray of light that is going, because it met maybe an obstacle, so it will divert. So that is what we call reflected ray. Then let me show you, when you are looking at diffraction. Diffraction is in this form. If peradventure we have a thick substance here, a dense, let's say a dense liquid here, and less dense here. So when you have a rays of light that moves like this, because it's changing from one medium to another medium, so it will now turn again. But just a bit of deviation, because it has met another, is going, and it met another medium, probably a less dense than where the light was coming from. It will just tilt a bit. That is diffraction. But when you are now talking of interference is like when you have a wave coming like this that is moving toward this way. When they get to a close point, let's say you just have an opening. Let's say you just have an opening like this. Look at this wave. You know, a straight wave that is coming this way. This is the direction. So it's coming. So these waves met an obstacle on the road, and but because this obstacle have an opening, then it will change to this. It will become curved and begins to expand as it moves. So this is referred to as interference. No, sorry. This is diffraction rather. Sorry, this is diffraction. Diffraction. Yeah. Oh no. NEPA don't take light to. NEPA don't take light to. Gas to just a minute. I will need to go and off on my generator. Where is my second phone? Can't get my second phone. Okay, minutes. Let me just get my this thing put on my generator. Can't lay my hand on my second phone. Okay, I can see it. Just a minute. Let me put on the chain. This is what we face. This is what we face. So, like I was saying the other time, this and this is the same. This and this from one medium to another. From one medium to another. So this is interference is superimposed. When you have when you have a wave moving in this direction, let's just give an example of that. So when you have this and this wave, when the two come together to give just one, so this is interference. This is interference. This is interference wave. So let's go to the next question. Where is that thing? So let's go. Calculate the electric field intensity. Electric field intensity. Calculate the electric field intensity between two plates of potential difference. Potential difference 6.5 volts. When separated by distance, a distance of 35 centimeter. A distance of 35 centimeter. So see, you are giving electric you have to find the electric field. These are the data given. I told you need to write out the data given. So you are giving the potential difference. You have to find the electric field. We are also having the length. The length can be converted to convert the length to if you convert this one to meter, that is 35 divided by 100. So 0.35 meter. That is what we will have. Electric field is force over charge of the material. Is force over the charge of the material. Are you getting me now? So is this correct? 100 centimeter will give 1 meter. 35 will be 1 over 100. Yes, it's correct. Conversion of this, just divide by 100. You have that. So, and it's also based on the parameter given, is also the potential difference divided by the length. Are you getting me now? Actually, the electric field intensity is force over charges. So now, but because now we are from the question given, we only have the potential difference between the plates. The potential difference between the plates and the distance, that will give us the electric field intensity. So now that will be equals to 6.5 divided by 0.35. So you just use your calculator and you get your answer. So you are having 6.5 divided by 0.5, 3.5. So 18.57. 18.57. So the unit is going to, you derive your unit from here. That will be Newton. Force is Newton. Per charge is C. So the unit for electric field is Newton per charge. So I'm coming. They just brought the lights again. Let me switch it. Let me off my camera. This thing, my generator. Okay, let's do the do. Let's do the do. Let's do the do. Let's do the do. So the next question here is we're having the distance between the image and the object in a plane mirror. Distance, if this is the image, this is the image, distance between, this is the mirror, this is the mirror. You know, if this place is x, the object also is going to be, let's play the object here. This is the image, and here is the mirror. So if you are having this place, the distance between the object and the mirror, if you are having it as x, so it's going to be the distance between the image and the mirror. So the distance of you seeing yourself in the mirror, as far as you are to the mirror, is the same distance the image will be to the mirror. So now let's see the question again. But we are given that the distance between the image and the object in a plane mirror is 40. So the distance between image and the mirror is what? Is 14 centimeter. So which means if from here to here is 40 centimeter, so what is the value from here to here? So here will be 20 centimeter, here also be 20 centimeter. So the question is now, if the distance of the object is reduced by 9.2, if you reduce this by 9.2 centimeter, so this is the new place of the object, so you reduce this by 9.2. So the question now is, what is the distance of the object from the mirror? What is the distance of the object from the mirror? So this place. So what is that? That is 20 minus 9.2. 8 point, here is 9, 0, 1 meter square, centimeter. Did you understand the flow? Did you get the flow? They said the distance between object and image on a plane mirror is 40 centimeter. So the distance of object to mirror is the same thing as far behind of the image in the mirror, which is we are having, and it is going to be equal 40 to be 20. Now they said if the object is reduced by 9.2, so what is now the distance of the object now to the mirror? So as you have known that from here to here is 20, from here to, you reduce 20 by 9.2, so the answer is going to give you 10.8 centimeter. So let's move to the next one. So the next question here is find the potential energy of an object of mass. We are giving potential energy, we are giving mass 10 kilogram, we are giving acceleration due to gravity 10 meter per second square, and we are also giving the height, which is 10 meter. And don't forget that the potential difference is mgh. So mass 10 multiplied by 10, gravity multiplied by 10, 1000 joule. 1000 joule. 1000 joule. The unit of so the unit of potential difference is joule. And don't forget if you remember the first question we solved, that we find the quantity of heat, which is mc theta. We equated it to potential energy, which is mgh. Why do we equated them? The energy, the quantity, the heat transfer, the quantity of heat is in joule, and this one too, the unit of potential energy is also in joule. So that was why we were able to equate. I hope you got the flow. Now we are moving. Since this one is, just know that potential energy is mass times acceleration times height. Now the question we are having here is that the volume of a fixed mass of gas, the volume, can somebody remember that law? Whose law? The volume of a fixed mass of gas is where am I? The volume of a fixed mass of gas is volume. We are having 10 centimeter cube. I can call this one V1. We have P1 as 400 centimeter mercury. We also say determine the volume of the gas when its pressure is V2 is unknown and P2 is equal to 200 centimeter mercury. So you remember that Boyle's law say that equal volume is Boyle's law. I think it's Boyle's law. P1 V1 is equal to P2 V2. So P1 is 400 multiplied by V1 10 is equal to P2 200 multiplied by V2. So V2 will be 4,000. 10 times 400 divided by 200. This cancel this divided by this. 20 centimeter cube. I hope you got the flow. Do you get the flow? I hope you got the flow. It is Boyle's law. Do you got the flow? Avogadro's law ló sọ wípé equal volume of all the gases at the same temperature pressure contain the same number of molecules. So let's go. Let's go. So just remember, I told you, even though if you don't remember Boyle's law or this, since the parameter given, you're having P1 V1, P2 P2. Just know that, let your mind go to something that, okay, you can be manipulating and you will be getting your answer with the units. So the next question, the question is, has the same unit as this thing, has the same unit. It has the same unit as A. We have impulse. B, we have power. C, we have force. And D, we have work. So these are the options. So the question is, this PV, which one does it equivalent to? Is it impulse, or is it power? Is it force? Is it work? So the correct answer here is work. And I'm going to tell you why. I'm going to show you why. Now look at PV. If you do your dimension, I think is the first this thing in physics. I don't have textbook. I think is the first topic. This your dimension analysis. Let's dimension this. What is pressure? You know, we can say pressure is force over area. Another formula for pressure is force over area. I hope you got the flow. John, if you don't know it today, that force can also be force over area. That's that. Then volume, we can replace it as length raised to power 3. That is length times length times length. Don't forget that the unit of volume could be centimeter cube, could be meter cube. Are you getting me now? So now, force. What is force? Force is Newton. What is area? area could be centimeter square or meter square. So we can replace it as length and length. Do you see now? Multiply by length, multiply by length, multiply by length. So 2 of it, take this, which we are left with Newton length. And don't forget that work is the force multiplied by the distance moved. Force, a work is the force multiplied by distance moved. So if work is force times distance, then what is this? Force and distance, Newton length or distance. I hope you got the flow. So that is why PV is equal to work. Whenever you are given another one, you have to break it down. You have to break it down by dimension. When you look at their dimension, you will be able to know the right answer to pick. I hope you got the flow. I hope you got the flow. I hope you got the flow. Repeat or continue. Repeat or continue. Thank you, Father Mika. God bless you. Repeat. I saw continue. I saw one repeat. If I see any more, I can quickly just go over it. Is it the only one? Okay, let me just quickly go by it. So the question is this: PV is equivalent to what? P is force over area, and volume can be area times length. I hope you know. This is another way of doing it faster. Are you getting it now? So volume is force over area. Pressure is volume over area. Volume is also area times length. This is another way. Pressure is force over area. Volume is area times length. So if area cancel area, we are having force and length. And work is the force multiplied by length, distance covered. So the PV is also equivalent to, has the same unit as work. So I hope you get the flow. I hope you get the flow now. So we are moving. See here, this question: what is the cost of running 7 watt lamp? What is the cost of running 7 400 watt lamps and 580 watt lamps? If for 12 hours we are running this, everything here, we are running it for 12 hours. Then if the electrical energy costs this, the electrical energy costs 7.00 kilowatts. So now the question is, yes, you have, maybe in your room you have 7 of 400 watts, maybe in your room and parlor. In your kitchen and bedroom you also have 580 watts of the same type. Now, and you are running it for 12 hours. How much are you going to pay? Now we need to find the total energy consumed, which is total energy consumed will be 7 times 40, and that will give us 0.28 watts. Then 5 times 80, and that will give us 0.40, 400 watts. So the total will give us 680 watts. You see something? Since this will give us 680 watts, look at this. The unit we are having here is kilowatts. So we have to convert this one to kilowatts by divided by 1000. So that would be 0. Yes, 0. Okay, before we convert to this, you know, watt, which is the energy consumed, is power times time. Power times time. That is the cost now. They said the cost is this now. This is the cost of electric. I told you now. The question says that energy cost is this now. This is the energy cost. So now power usage is power times time, which is equal to 680 times 12. So once you know this one, it will be 680 times 12. So that is 8160 watts. So we need to convert this to kilowatts. It will be 8160 divided by 1000. That will give you 8.16 kilowatts. So now, if I think they are referring to this as per unit consumed, as per unit consumed. So if this is as per unit consumed, then, and you have seen this one, charges. So the total amount to be paid will be equals to total cost now will be equal to 7 multiplied by 8.16. So that will give you the answer. Energy, yes, this is the energy now. Don't forget you are calculating the cost of running the lamp. Is calculating the cost of running the lamp. That's what you are calculating. And we already know we are giving 7 watts of a lamp that is 40 watts, 7 of it. There's a lamp that is 80 watts, 7 of it. What is total watt? So the total watt is you multiply this and this, you add them. You know, energy is power times time. So that is how we roll. That's what we are saying. So now if we multiply this now, we have 7 times 8.16. So that is 57.12. Let's see. 57.12. That is the answer. 57.112. Let me even see. Maybe it's typing error. They didn't put the unit. They should have included naira here. They should have included naira in that place. Okay, there is naira there. So there is naira here. So this is the total amount. This is the total amount they will need to pay. 57.12 naira. Just understand the flow that now you multiply to calculate the total watt of 40 lamps. 40 lamps is multiply this to know the total. And this run for 12 hours. Energy is power times time. So we know the power, which is this, times time, 12. We are getting this. But because the cost, the unit cost is in kilowatt, so we have to convert this to kilowatt by dividing it by 1000. So when you divide this by 1000, you have 1.8 kilowatts. So since we are having a unit is costing this, if a unit is costing this, multiply by this, That will give you the total amount you need to contribute or you need to pay. So we are in number 16. Here we have to calculate calculate the specific latent heat. Specific latent heat. Latent heat. We have to calculate latent heat. We have to calculate latent heat of vaporization of steam. 1 point, we are giving energy, heat energy. We are giving heat energy to be 1.13 times 10 raised to power 6. 1.13 times 10 raised to power 6 joule of heat energy required to convert mass of 15 kilogram of heat to water. So we have to calculate the specific energy. You know, heat is equal to mass times specific energy. You remember? I hope you know this formula. But I'm coming. Why is there no theta? Why is there no theta? Does anyone know? Why is there no theta? You know, we're supposed to have MC theta. The reason is this. Because it is latent. That is why we are not adding theta. Because it is latent. There was no change in temperature. That is why we are not adding if Adamika, you are right. So because it's latent, that is why. What is latent? Remember, the boiling point of water is what? The boiling point of water is 100 degrees centigrade. I hope you get it. Now, it will get a point. Once you boil the water and it gets to 100, there is no amount of heat you will apply. It will not pass that 100. The heat in that water will not pass 100. But we are still applying heat. This heat you are applying, what is now happening is what we call latent heat, because there is not going to be a rise in temperature. The temperature is going to be the same. If you heat from now till tomorrow, the temperature is going to be the same. Thank you. I see you, Micah. So that is why we are not adding temperature to this. Now, from here, we can make C the subject of formula. We make C the subject of formula. You have Q over M. And we have been given that 1.13 times 10 raised to power 6 divided by 15. So that is specific heat will be joule per kilogram. So let's use our calculator and see what we have. So here, this is how I'll multiply 1.13 times 10 raised to power 6 is equals to divided by 15. So we're having 75,333.33. So you can convert this one to, this is joule per kilogram. You can also change it to 75.3. That would be kilojoule per kilogram. So it depends on what we have in the option. It depends on what we have in the option. So we are having, okay. So this is correct. You can take this to standard form and say 1, 2, 3, 4, 7.5 times 10 raised to power 4 joule per kilogram. So they put it in standard form. So that is how we roll. So the correct answer is C. So let's go. Now we have A stationary wave pattern. This is a wave question. A stationary wave pattern is formed by a wave of frequency. We are given frequency 40 Hz, and velocity. We are given velocity 60 meters per second. So a wave pattern is formed by a wave of frequency 400 Hz and velocity 60 centimeter at 60 meters per second. What is the distance between the adjacent nodes? What is the distance between the adjacent nodes? If you look at this, if you have something like this, and it's moving, you have a wave moving this way. So now the distance between two crests, you call this here crest. So the distance between two crests, that is what they are saying, the adjacent node is wavelength. This is wavelength. So now, what is the relationship between this and this? Does anyone know the relationship? The relationship between frequency, velocity, and wavelength. Wavelength. Wavelength times frequency. Wavelength times frequency. So and we are wavelength. So wavelength will be velocity over frequency, which is velocity is 60 meters per second, frequency is 40. So that is 3 over 2, 1.5 because it's wavelength, and we are having meter here, 1.5 meter. So I hope you get it. Do you get the flow? Do you get the flow? Do you get the flow? We are not dividing it by 2. We are not dividing. They are not asking us. They say we should calculate the distance between the adjacent nodes. If you are looking at this way, you will still go one more time. I don't know if you are my this system here. This thing cannot see it. So let's not use this one. Or if you are looking at this way, so the adjacent node from here to here is a wavelength. You are not dividing by 2. So let's go. I hope you understand. Just know the formula. The formula that connects. Like I said, physics, especially physics, is something you can guess and get your answer by looking at the parameter given. When you look at the parameter given, you can get your answer. So calculate the light of the image formed by a pinhole camera. Pinhole camera. A pinhole camera does not have the camera. A pinhole camera does not have a lens. It does not have lens. So you may have it this way. So the camera. So we are given that calculate the height of the image formed by a pinhole camera of length. The whole camera of length 12 centimeters used to photograph an object 60 meters away. 60 meters away, and this is the height of the pinhole camera. The height of the pinhole camera 12 meters. The height of the pinhole camera, okay, centimeter. So this is the object. So the question is a way. Okay, we have to calculate the height when even the camera itself is 70 meter high. Is 70 meter high. We want to calculate the height of the image. The height of the image. Are you seeing now? The height of the image. Let's call it HI. We have to calculate the height of the image. This is a pinhole camera which has a 12 centimeter. The eye alone, 12 centimeter. The height of the camera is 7 centimeter. The object is at a distance of 60 centimeter. And what is now the height of the image? There is a formula you need to know that the height of the image will just be equal to the height of the image will be height of the camera multiplied by the height of the pinhole, height of the pinhole divided by the distance of the object. The distance of the object. Let's call it the object. So just put this into your score. So that is it. If you are given the height of the image, if you are given height of the image, in some question you'll be given the height of the image and ask you to calculate the height of the camera. You can cross multiply and find that. If you are given height of the pinhole, or maybe you are given the height of the camera, you are given the distance object, and you are given the height of the image, and you have to calculate this, Mr. Man, you use it. So that is how we roll. So we can place the value now, which is equal to 70 times 12 divided by 60. So that is what we produce. So let's take calculator. We have 70 times 12 is equals to divided by 60. That is 14 centimeter. So this is the image, this is the height of the image that we produce. So the last one, let's see the last one. Second to the last one. I hope you understand. Second to the last one. Second to the last one. Second to the last one. You have something like this. You have a diagram. You have a diagram. This is 8 microfarad. This is 10 volts. The question says from the diagram above. This is the question. From the diagram above. From the diagram above, calculate the energy stored in capacitor. Energy stored in capacitor. Just know this formula that energy stored in capacitor is equal to 1 over 2 CV square. This is the formula. Put it in your score. That energy stored in a capacitor. This is what we use. From the diagram, 1 over 2, we have the capacitor. This is the unit. And don't forget, this is microfarad. Micro is 10 raised to power minus 6. Micro is 10 raised to power minus 6. So we are having energy store is equal to 1 over 2. 8 times 8 times this value is micro times 10 raised to power minus 6 times volume 10 times 10. So let's find the final answer. Let's find the final answer. So we're having 8 times 10 raised to power minus 6 equals to times 10 times 10 equals to divided by 2. 4 is 4 times 10 raised to power minus 4 from the calculator. So it's going to be Joule. Joule. So correct answer here is B. So all you need to know, physics, you have to solve so that you'll be able to familiarize yourself with so many formula. Kindly, if you are going for JAMB, please get a past question, series past question, and go through them. You will see a lot of formula that you will not even imagine, I may not have come across in textbook, and it's there, just that they didn't move further. So please do that. So now this is the last one. I want to do it because it's an objective question. Say which of the following is a scalar quantity? Which of the following is a scalar quantity? Can anybody define a scalar quantity? Scalar quantity in the building. Who is dropping scalar quantity in the building? Scalar quantity is a quantity that has what? A quantity that has magnitude but no direction. A scalar quantity is a quantity that has magnitude without direction. Without vector quantity, a quantity that has both magnitude and direction. So knowing that, so pick your correct answer here. First option here, we are having A to be tension. We are having B to be weight. We are having C to be impulse, and we are having D to be mass. So drop your answer in the comment section. So we shall continue another day, until further notice again. Rona boy said D. Micah said D. Sani Ezekiel said mass, which is D. Koski said mass, which is D. Ashumbahat. Bam bam. Ayo bam bam say as. So the correct answer is the mass. So try to know more example on scalar quantity and vector quantity. So another question may come and you may not see mass, and they put another quantity that is scalar. So now let's solve a bit of mass till I went in by 1, and it's going to be WASS question. That is SSC question. Let me see where that. We're solving I don't know. So the Y set, are you in the building? What is it? West Africa Senior Secondary Certificate Examination. Yes, so all fundamental quantity. Length is also there. I see you. So we stop at so the question we are having here is the circumference of a track. The circumference of a track is 9 kilometers. The circumference of a track is 9 kilometers. A cyclic right round it. A cyclic right round it. Let me draw it bigger. The circumference you have from here down to here, I call it S. So the circumference now is 9 kilometers. So moving this way, this way, this way, this way until you get to the point, initial point. So it's 90 kilometers. And then a cyclic begins to move around this track. Probably is a feed or so. Thank you, Marka. I told you that I'll just try my best. So now a cycling rider round it a number of times. Maybe it's a lane or it's a feed. You know, you are now moving around the feed, and the total, the summation of all of one circle of round moving around is 9 kilometers. So they now said that this, after covering a distance of 300, the cycle begin to move and cover a distance of 302 kilometers. How far is the cyclist from the starting point? How far? Look at something. Let's clean this. I hope you understand. Circumference now. Circumference is the total. So let's say this is the field. Let's say this is field. A cyclic starts at this point. If we can, and the length of this whole field now is 9 kilometers. So, and a cyclist, let's say C, begins to move. He's moving, and now cover a total distance of 302 meter. Is it kilometer now? Let me check out if it's kilometer. Where are we? Okay, kilometer. Okay, this one is kilometer. This one is also kilometer. Are you getting the flow? I hope you are getting the flow. Now, you are now saying, you know, it will begin to move around. This 300, we don't know where it stops. Let's say you finally stop at this point. This is now the final point. Initial point and final point of the cyclist after moving several hours. They are now saying that, what is this distance? Thank for the gift. God bless you. So they are now saying, how did they now move? What is now the distance of this bike from its initial position? So we call it S. You see now, the cycle was moving around the circle, and then it covers 302. So you cannot say if this is actually covers up to this place. All you need to do, you need to find how many times did this bicycle move. 302 divided by 9. So what will this give us? That is 302 multiplied by divided by 9. That is 33.55555. So 33.5555. What do you think? What do you think happens here? It means that he completed 33 moves. He completed 33 moves from one to end. He moves 33 times. Are you getting me now? Look at this. And he has begun the journey again. 0.55. He has moved just 0.55. And don't forget, he's moving what? The circumference is what? Is 9 kilometers. So for you to know the distance where he is and from the beginning will now be equal to 0.555 times 9. So that is what the answer will give us. Because anyone he has completed, you can't add it now. Because if he has moved 1, so if you are moving 33 times, so there is no distance left. There is no distance left with this. So the distance left is this. And now, but because the circumference is 9, that means the length is 9. For you to now know the distance moves, you have to multiply by 9, the circumference. So that would be the distance between the initial and the final position. I hope you got it flow. Let's multiply 0.555 times 9. So 4.999. 4.99995 kilometers. So which we can approximately to 5 kilometers. So there's no 4.999 in the option. So but 5 is there. I hope you got it flow. The next flow we are having here is 2 root 2 minus 14 root 7 minus plus 7 root 21. How do we do this? So you need to find the LCM first. What is the LCM? Is root 12. Now before I write root 12, you know I can split root 12 to root 3 times root 7. Do you agree with me? Root 21 can be root 3 times root 7. I hope you agree with me. If that is the case, I'll put root 3 multiplied by root 7, which is a total of root 21. If that is the case, this one is 1. 1 in root 21 times this, you have 2 root 42 minus 7 root 7 cancel this. You are left with root 3. We have 14 root 3 plus this cancel this. You are left with 7. So 42, does it have a perfect number? 42. Okay, 42 divided by 3. 3 here. What do we have? I hope they will even write the question here. 1 in 12, 4. 14. Coming. Then, what else do we have? 7 here, 2. Then, 14. 2 here, 1. I'm just trying to find something to factorize here. I'm gonna find something to factorize. So, I hope you are getting the flow. So now, I can split this to be 2 into root 3 times root 14 minus 4 root 3, then over root 3 times root 7 plus 7 over root 21. Let's leave that one there first. So something is common. We are having root 3 into 2 root 14 minus 14 over root 3 times root 7 plus 7 root 21. So root 3 cancel root 3. We are left with, I don't think they put the question well. Maybe it's typical error, but we will solve it to the simplest one. So we are having this cancel this. We are left with 2 root 14 minus 14 over root 7. Then plus 7 root 21. So if we find the LCM, same again. Let's find the LCM of the two. The LCM of the two will also give us root 3 multiplied by root 7. That will give us 21. If this cancel this, you have 2 root 3 times 14, 12, 1, 42 again. We are back to where we are. Minus 14 root 3. I think I'll have done what I need to do. Plus 7. So, which means this is the answer. I've even gotten the answer from here. I hope you got the flow. Probably they didn't put, let me see if the correct answer is there. Maybe they didn't write it well. Maybe they didn't write it well. They didn't write. Probably they wanted to write, let's solve this one. Let's solve it this way. Maybe it's the typing error. Let's solve this way and see what we have. Let's say it is 2 root 7 minus 14 over root 7 plus 7 over root 21. So LCM is, you know, we can split this as, why I'm splitting this is for me to cancel 7. Root 3 multiplied by root 7. So if root 7 cancel this, we are left with root 7 cancel this. If root 7 cancel this, we'll be having root 3. Root 3 times this, you have 2 root 21 minus root 3 times 14. 14 root 3. This cancel this, you have plus 7. That's what you have. Then root, this one is 21. You can now rationalize by root 21, root 21. Rationalization. So this and this will give us 21. This and this, that is 2 into square of 21. This square 4, this square 1. This times this, 2 times 4, 4. So it's 441. So 441. So 441. I hope you are getting the flow. If you are not getting, just say I should repeat. I rationalize from here. So root 21 times this, that will give us minus 14 root 363. Then plus 7 root 21 divided by 21. So that is still not clear. You can still simplify this further. That is 2 into 1 square root of 1 is 21 minus 14 root 63 plus 7 root 21 over 21. So I think it's typing error. They didn't put the question right. Let me see if I can get the way they place the question. No, you don't do. You can't do that way. It will not work out. It's to just get the right question. Once we have the right question, we solve it. Once we have the right question, we solve it. Do re mi sa sa re mi do re. Is this 14? 7. Let me see from here. Let me see if I can derive the question. Let's see if we can get the right question. So if you're having 2 root 3 or 1 minus 14 over root 7 plus 7 over root 21. So this one is 21. What if it's 7? This is 7. 21 times 7. 7. 7. That is 14. So 49 times 3. 49 times 3. That is 27. Okay, I've gotten the question. So I've gotten the question. So this is the question here. This is the question. Is 2 root 7 minus 14 over 7 minus 14 over 7 plus 7 over 21. So that is the question. So let's look at it. So we are having this one is over 1. What is the LCM? Notice it's root 21. Root 21 can also be split as root 3 multiplied by root 7. But let's put root 21 here. 1 is root 21. Root 21 times this. That is 7 times 21. You have 2 root 147 minus root 7 will take away root 7. We are left with root 3. 14 root 3. And root 21 will take away root 21. We are left with 7. I hope you get it. Now, don't forget that I thought when I was doing solve last time, I said 147. Look at the least number that goes. 3 goes in 14 4 times. That is in 12. Remainder 2. 3 goes in, that is 9. So we can change this one to 2 root 49 times 3 minus 14 root 3 plus 7 over root 21. So root 49 has square root times 7. Square root of 49 is 7. Root 3 minus 14 root 3 plus 7 over root 21. So this becomes 14 root 3 minus 14 root 3 plus 7 divided by root 21. So which is equal to, this will take away this. We are left with 7 over root 21. We rationalize 21 root 21. So this will become this becomes 7 root 21 over 21. Root 21 times root 21 will give you 3. Root 21 over 3. Is that clear? Is that clear? So, we are stopping by 1. I think this is 2 minutes. Let's solve one more question. Let's solve one more question. 2, 3 question, 4 question. I will be going to work tomorrow. So, what you'll be having, we have to solve if 4x plus 2y equals to 16, and 6x minus 2y is equal to 4. Find y minus x. You got a flow. Saka. What do we go do? See you in the build. The first show. The shoe shine. I got the flow. I got the movement. Look at it. They make it easier. Y here is equal to y here. The same sign. You add 10s equals to 20. S equals to 20 over 10. S is 2. Use any of the equation. 4s plus 2y equals to 16. Anywhere I see s, I put 2. 4 into 2 plus 2y equals to 16. 8 plus 2y equals to 16. 2y equals to 16 minus 8. So y equals to 8 divided by 2, which is 4. So y minus 2, 4 minus 2. So the answer is 2. Is that clear? Repeat or continue? Repeat. I see you, may your lean build. I got you in the system. Queen Clara Mode, I see you in the building. I got you in the business. Repeat or continue. There's a question I got you. Okay. I think we stop here today. Continue from here tomorrow. Tomorrow we continue from there tomorrow. I said to repeat this. Let's repeat this. Hey, see this one. They make y and in equation 1 and y in equation 2 have the same constant, the same coefficient. If they have the same coefficient, if you cancel it out, what you cancel out have the same different sign. Once it has different sign, you add the remaining. Once it has the same sign, you subtract the remaining. The same sign in the sense that if it is minus minus or plus plus, the remaining you subtract. Or if it is plus minus or minus plus, you add. So this is plus minus. Add 4s plus 6s, 10s. This one becomes 0. 16 plus 4, 20. Divided by 10. S equals to 2. Put 2 in any of the equation. And look for the simplest one. Is 4x plus 2y equals to 16. So wherever I see x, I place 2. 4 into 2 plus 2y equals to 16. 4 times 2, 8 plus 2y equals to 16. Collect terms. 2y equals to 16 minus 8. 2y equals to 8. Divide 0 by 2. Y equals to 4. 4, 8 divided by 2, 4. Question says find y minus s. Y is 4. 4 minus s is 2. S is 2. Final answer. I hope you got the flow now. I hope you got the flow now. And then we can call it a day now. We start another day. Marker don't finish, yo. Marker don't finish, yo. So that is how we roll. Let's meet here tomorrow again. Thank you. Bade Keshin Olawale. Appreciate that. God bless you. Appreciate it. God bless you. There's one. I need to record that. You are too also. Hey, thank you guys. God bless you. I see you. Bade. I just gave you a follow. Good night. Night. Everybody, good night. Who else in the building? Oh, Wolabi, I just gave you a follow. See you in the building. Good night. Bye. Good night. Good night.